this is looking down the bore of the cylinder, and you can see the amount of gap space. This is because the cylinder is cut that way for some reason. I wish it was cut a little better as far as a little tighter diameter. And you can see how huge that exhaust port is. But this is what I want to show you about the problems that we run into. If you will look down on the edge right here, this is the front, you'll see that the cylinder bore goes almost all the way down. It'd probably leave about a 1/16 of an inch of aluminum that you can see on the sides. Now that's no problem, and you can't see it over here, but you have to remember that that piston skirt may hit right here, or the edge of it is likely to hit here or right over here. And that's what I found on that. So I like to put the piston on, and then I'll take my little pair of pliers and I'll run the crankshaft all the way through its rotation 360 degrees and see if I can feel anything hit. If anything hits, then you got to take it all apart again and recheck it. You may have to do this 40-50 times, doesn't matter. Here's the top of the cylinder head on, and like I say, usually I'll have this part coming out the front. This is only on there to see how well, if there's going to be any knocking or hitting or anything like that. Yeah, let's see. And these, I really like these cap screw. You can get really good torque on them, and they just seem to work really well. And there's your intake, and then you can see the base gasket underneath it. Now, this is your, and I call it, the base gasket can also be your deck height. It's very important that you put gaskets come in copper and steel and aluminum or fiber, and they come in different thicknesses so that you can raise the cylinder slightly or lower it. And that's all depending on the piston that you use, because you want the piston to go right to the top of the the cylinder, but you don't want to go in too high or too low. Too low, you lose compression. Too high, you're going to slap the top of the cylinder head. Now, in order to get your best flow according to the books, you can see there's black paint in here. You can see this right in here. Now, if you were to take your 120 millimeter Dremel roll, you can smooth all this casting out. Actually, you can almost make it like a mirror if you take your time and polish it. And I like to do that. I don't know if it really helps, but it's supposed to be better than having it rough. And this is what it looks like in the front. Now remember, this is all mocked up. This is not final fit or anything. I'm just seeing if there's any leaks or anything. Not leaks, I'm seeing if there's anything knocking. And here you can see the base gasket in the back, and that's where this is where your boost port is. It goes right up through here, and right about there it opens up on the inside. That's not too good. Oh, look at that. That's even better. That's even better. And you want to keep your case integrity right? This is the back. Your back tire is going to hit around here. The reason I have all the little white speckles, this is oxidation due to the oxidation due to the dishwasher. And then you see these little black parts right here. This is road tar, and you get that on the hot motor, and it's hard to get off. It doesn't hurt anything, but it's nice to keep everything as clean as possible. And the reason for that is that if you have a leak or something like that, you can say the motor was perfectly clean when I had it there before. Now here's the intake, and I've widened it out 10%. This is rough right here. It's supposed to be rough, they say in the books. I've just polished it up. And this edge right here, what I've done is I usually like to make a knife edge right in the very front because of the fuel going in there, and then on the other side I make it knife edge so that it's kind of like an airplane wing. I don't know if it helps, but it makes me feel better, so that's the way that works. And here's my dummy bearings and my oil plug, and it's all ready to go. And I put the oil plug right there just so that you can see what it looks like, getting a good round picture of it. I like to put a little bit of oil on this and a little bit of two-stroke oil on the bottom when I go to fit it. And you'll have to use something to hold it in. It's very important that you use your Q-tips in this area and everything down in here that you can't see. You want to make sure there is no little tiny bits of aluminum which are going to get in your motor. And this is the thing that I found, and I don't know why it is that way. But this, oh, come on. Your crank comes right about here and goes through the case. For some reason I found a bunch of little nicks on here, and I don't know why. But on my future ones, what I'm going to do is I'm going to take my little Dremel and take off a 1/16 of an inch right there, a little, just so I make sure that the crank doesn't hit on it for some reason. Just every time I build a motor, I may find a little bit of a problem, and I just learned about static balancing, and I've tried to find things on the little two-stroke cranks, and I live in a small town. They don't have that much information on anything. So I found out about static balancing, and a big mistake I've been making on my engines. Now here's the plug inserted, and then I'll clean that off real well and use JB Weld around it. This motor is all ready for 54mm cylinder or a 52.5mm cylinder and a 50mm in diameter stoker crankshaft. And I do a little bit of work here and there. The big problem with the piston skirts, or the very bottom of the pistons, they will either hit right here, or they will hit right where this purple edge is right here. And I found that out because I've taken the motor apart and I found little tiny nick marks. Even if you go to run it or go through the motions while it's not running, when it heats up, it's going to heat up and stretch just a little bit. And then, like I said, in the center here, I like to put a knife edge on it. And here's your I know I have a lot of pictures, but they're close-up pictures, and I can come back and refer to them if I need to. You know, for some odd reason, I've done that before. I've taken a carburetor apart, and this was something I tried to do. This is where you're supposed to, you freeze your bearings, the new bearings, and they come in little packs like this. And what that does is it shrinks the metal just a tiny bit, and then you're supposed to heat up the cases in your oven. So what you do is it will shrink the bearing a little bit, and it will expand the case with the heat, and then these are supposed to drop right in, but I haven't been able to do that. So what I do, and it's worked for me, is I will take a big 2-inch washer, and I'll put the bearing, these are the dummies right here, these are the new ones. I'll take the new ones and put them in here, no oil or anything like that, and I'll take my washer here and I'll just pound them in, and you go, oh my God, it'll hurt it. Remember, they're little tiny bearings. Nothing fancy about them at all. And they come with a little bit of grease on them. You don't want to put them in until after you make sure everything is fit, and that you know it's going to work. So we have our new rods, our new bearings, everything's clean. And here we have, these are the little dowels that come. These are the ones that you put on your motor intake front bolt to keep the motor from rattling if you have a 1993 frame. And then your piston, and these are primary gears or secondary gears, and there is a 6.5 primary, I believe it's a primary gear. Let's see. And you can see that this bearing has been fit in there. You want to make sure it goes in and it does not spin on the outside. Some of them, these little motors go through hell, so bearing inserts are next.